Alright, welcome back everybody. Today's topic is price discrimination. So this is the second model that we see in our discussion on adverse selection. So this must be familiar to you. There are three types of price discrimination. The first one is called first degree price discrimination. It's also called individual pricing or perfect price discrimination. In this price discrimination, a seller knows every consumer's willingness to pay, so it's like full information benchmark. And in this case, the seller gives an individual specific price. The second type is called the third degree price discrimination. It's not the second degree price discrimination. I listed these types of price discrimination from the one which requires the most precise information to the one which requires least information about consumers. So the second type of price discrimination is the third degree price discrimination. It's also called group pricing. So in this price discrimination, a seller knows a consumer belongs to a specific group and also knows the distribution of the willingness to pay of those in the group, and then the seller can give a group specific price. And the last one is called the second degree price discrimination. It's also called menu pricing, and in this price discrimination, a seller does not know any of these, so it requires the least amount of information, but only the distribution of willingness to pay. So a seller knows only the distribution of willingness to pay. So I don't exactly know why these types of price discriminations are called in this way. We just follow the tradition which starts from Arthur Pigou. He categorized price discriminations in this way, and as you can see, the second degree price discrimination requires the least amount of information, and in this situation there is a clear asymmetric information about buyer's willingness to pay. So we want to focus on the last case, the second degree price discrimination. So here is a model. There are two types of consumers. One is high demand type, the other is low demand type, and they are denoted by this theta H, theta L, and the mass of each group is half. So half of them is high type, and half of them are low type. And utility of type I consumer is given by this U function, which consists of two parts. The first part is theta times V. Theta times V is the gross utility that the consumer enjoys from consuming this good. And the second part is the is the disutility of paying price. So this theta times V is the utility that this consumer enjoys because he consumes this good, and the T minus Q, minus T of Q is the payment that this consumer is making. So the consumer pays as much as T, and it's not denoted by P. It's denoted instead by T. T stands for tariff. Tariff is some sort of tax in international trade literature, but in industrial organization and in contract theory, T stands for tariff, and tariff is some generalized price. So it's basically just price. So the first term is the utility, and the second term is the price, or disutility from paying the price. Okay, and here we'll assume that this V function is a quadratic function. We want to be very specific about this V function. So V function is quadratic function, so it's like Q minus Q squared of 2 theta, and we'll assume that Q must be smaller than theta, and the price T of Q is the price of this good for a given quantity Q, or quality. So Q can Q can represent quantity or quality, but in price discrimination context, it's better to be interpreted as a quality, because if it is quality, then it is not possible to sell some quantity, sell some of the good to some other person. So we don't have to think about the second-hand market. So we'll assume that in our discussion, we'll just call it quality. Q is the quality, and from this utility function, we can derive the demand function of each group. So demand function looks like this. DL is the demand for the good of the L-type consumers, and it is theta L minus P. And demand of the high-type high-type consumer is DH, which is theta H minus P. So we can think of this demand function only if there is some unit price P. So if there is no unit price P, then we cannot even think of demand function. And as we'll see soon, this demand function can be obtained by solving the utility maximization problem of consumer. And we'll assume production cost is simply C times Q, and we'll assume C is small enough. And what this assumption means is that the marginal cost is constant, marginal production cost is constant, and that is given by C. And we'll assume C is small enough so that everybody can consume this good in equilibrium. Okay? So, as I said, demand function can be obtained by solving a utility maximization problem. So, I often ask this question in my course, in my lectures. What is a demand function? And some in basic in elementary economics course, in microeconomics courses, demand function is a consumption schedule given price, right? So that's one interpretation of demand function. And in other more advanced courses of microeconomics, demand function is the solution of utility maximization problem. So demand function can be obtained by solving this utility maximization problem, which now you are seeing on this slide. So you maximize the demand function, the utility function, which is given by this theta times Q minus Q squared over 2 theta minus P of Q. So this minus P times Q. P times Q is just T of Q here in the equation, in the definition of the utility function. T of Q is the total price that the consumer must pay for quantity Q or quality Q. Okay, so if we assume that there is unit price P, constant unit price P, this T can be written like P times Q, right? So that's what I wrote here. So the theta times V, that's the gross utility of consuming this good. So theta times V is shown in the first, and the P times Q is the total payment that this consumer must make. So this total payment T of Q is just P times Q, right? And you maximize this utility function by choosing the right Q. So you differentiate this objective function with respect to Q, then the first of the condition is just simply given by this theta minus Q minus P equals 0, right? So it's a quadratic function, and the sign of the second order term is negative, so the second order condition must be satisfied. So the first order condition approach can be used. So the first order condition is simply given by this theta minus Q minus P. And if you move this Q to the right hand side, then we have the demand function. The demand function is the quantity demanded for given price P. So the quantity demanded given for given price P is just theta minus P. Okay, so this is the demand. So we can, so you have seen this linear demand function in many courses, many economic courses that you have taken, but maybe it's first time you have actually seen this demand function is derived from this quadratic utility function. Okay, so and you can see the demand functions on this diagram. So the demand function looks like this. So the slope is -1, and the intersect is either theta L or theta H. So the high demand type consumer demands more. So high demand types consumers demand function is larger. It is drawn on the outside of this lower type demand function. And for given price P, the quantity demanded is just QL or QH. Okay. And just one more thing about consumer surplus. From this from the demand function, you know how to calculate consumer surplus. Consumer surplus is the area of the triangle. The blue, for example, this blue triangle. The area of the blue triangle is the consumer surplus of the low type consumer for a given price P, right? But you can understand it in a slightly different way by integrating the first condition of the consumer's maximization problem. So to get the demand function, you differentiate the utility function, and then you integrate the marginal utility, or you integrate the first order condition, or the first derivative of the utility the first derivative of the utility function. Then you get the utility function. You get the utility function back, right? So the consumer surplus is simply the integral of the marginal utility. So as you can see in the mathematical expression, so you integrate this theta minus x minus p, which is the marginal utility. So we get this. So let's look at this slide. So in the first order condition, the second equation, right? So look at the second equation, is theta minus q minus p. So this is the marginal utility of this consumer for given price and given quantity, and you integrate this marginal utility over x over q from 0 to ql. Then you get the consumer surplus. So consumer surplus is actually just the utility that you can get from consuming as much as in this case as much as QL, right? So to get the third line of the equation, I replace QL by theta L minus P. Okay. So let me repeat. To get the third line, the last line of this equation, I replace QL by theta L, because QL is just theta L minus PL. Theta L minus P. Okay, so according to this demand function, which shows the optimal optimal amount or optimal level of quality to be demanded, this demand function is just, so QL is just simply theta L minus P. So I use that fact to get the third line of this equation. Okay, so that's exactly the area of this blue triangle. Okay, so you can see the relationship between utility and demand and utility, or consumer surplus and demand, right? So if you differentiate utility function, then you get the marginal utility, and you set the marginal utility equals to 0, net marginal utility equals to 0, then you get the demand function, and you integrate the demand function, then you get the consumer surplus. right? So consumer surplus is simply the utility function or utility for a given price. Okay, so let's move on to our main discussion on price discrimination. So let's first consider the first or the third degree price discrimination. In this case, we can distinguish the first and the third degree price discrimination because we assume there are only two types of consumer. So if you know the type, or if you know a consumer belongs to which group, then you know the type of the consumer. Exactly, you know the entire information that you need to know. Okay, so in this case, we cannot distinguish the group pricing from individual pricing. So the first degree price discrimination is basically the same with the third degree price discrimination. So we assume a monopolist, the seller, knows the type of consumer, so it's like full information benchmark. In this case, consumer surplus for a given price P can be written like this. So let's denote the consumer surplus by S. So SL is the consumer surplus of the L-type consumer, which is the area that we just saw, the area of the triangle, the blue triangle, right? So that's the consumer surplus, which is the theta L minus P squared over 2, right? So that's the area of the triangle. So theta L minus P squared over 2. So it's very similar to SH, so the consumer surplus of high type consumer. So SH is theta H minus P squared over 2. So before we decide the price, we just first calculated the consumer surplus because we want to use that. Okay, so the first degree price discrimination or individual pricing can be written like this. So the price is individual specific, so we have subscript I. So TI is the price that type I consumer must pay for a given quantity Q. So it can be written like AI plus PI times Q. So there are many ways to give this price, but this is just one way, and I think it is one of the most intuitive way to write down the first degree price discrimination. And it's quite flexible, and you can use it in many different contexts. So the first degree price, so the first best price for individual I or the type I consumer is AI plus PI times Q. So AI is the fixed fee or fixed price that a consumer must pay just to participate in this deal. And PI is the unit price. Okay, so TI is sum of fixed price and some marginal price or variable price. And it is optimal, as you can see in the next line, it is optimal to set the marginal price or the unit price P equals to C. Okay, so the optimal price, the first best marginal price is C. What is C? C is the marginal cost. So you set the marginal price equals to marginal cost. So that's how you maximize the surplus generated in this deal. Okay, so you lower the marginal price as much as possible to maximize the joint surplus, and then you absorb, you extract all the surplus generated by this transaction using this fixed fee A. Okay, so the low type consumer consume as much as theta L minus C, right? That's the demand. So for a given price C, the quantity demanded by low type consumer must be theta L minus C. That's the quantity demanded by the low type consumer. In that case, the surplus generated by the low type consumer must be theta L minus C squared over 2, which is the SL of C. Okay, and you extract the entire surplus using AL. So ALFB, the first best fixed fee, must be same with SL for SL of C. Okay, so that's how you maximize your profit. So to maximize profit, you first lower the marginal price down to C, the marginal cost. That's how you maximize the joint surplus or the entire surplus. You increase the pie as much as possible, and then you extract the entire surplus using this fixed fee. Okay, so fixed fee A must be same with the surplus generated by this transaction. Similarly, AHFB is SH of C, which is theta H minus C squared over 2, right? So that's how you maximize your profit, and this must be the way to maximize the profit, because you cannot generate a greater surplus, right? So you maximize the surplus by set the marginal price equals to C. So marginal price equals to marginal cost. So in that case, marginal cost must be same with the marginal utility of the consumer. So marginal utility equals to marginal cost. That's how you maximize the social surplus. And then you extract that surplus. So there is no other way to increase the profit, right? So this is a way to maximize the profit. And in this price discrimination, the first degree price discrimination, the consumer surplus is 0. So I must apologize for using this term in a bit confusing way. Here, the consumer surplus is exactly the consumer surplus or the consumer's utility by participating in this deal. So the consumer's net utility must be 0, right? Because the consumer enjoys using this good or consuming this good, and then the consumer had to pay a lot. So by this fixed payment, the entire surplus is transmitted to the seller, right? So eventually the consumer surplus must be 0. But this discrimination, the perfect price discrimination, maximizes the social surplus. How do you know that? The social surplus must be maximized when the marginal price equals to marginal cost. So P equals C means that the social surplus is maximized. So in this case, the equilibrium quantity QLFB and QHFB is given by this theta L minus C and theta H minus C, or it can be written like this. So these two. So you see the 4 equations. The first 2 equations are equivalent to the last 2 equations. So you can write in either way. So let's look at the bottom 2 equations. On the left hand side, you see the marginal utility of consuming this good, and on the right hand side you have the marginal cost. So in the first best situation, the marginal benefit of using consuming this good is same with the marginal cost. Okay, it's same for type L consumer and type H consumer, and this is the case when the information is perfect, which means the seller knows the buyer's type, or seller knows the buyer's willingness to pay exactly. So it's like, there are only 2 types of people. One type is student, the other type is non-student, and you can check whether a consumer is a student or not. And if the consumer is student, then you know the exact willingness to pay. You know theta L exactly, or theta H. And if you see a consumer who is not a student, then you can say that, okay, that this consumer's theta is theta L or theta H. Okay, so and by checking this identity or group identity, you can give different prices. So that's how you maximize the profit for given information. Okay. So let's move on to the next more interesting situation. So it's the situation where the seller does not know the type of the buyer. So that's the situation that we. So in that case, we can use the second degree price discrimination, or sometimes we call it a nonlinear pricing because it's not linear. So you can think of a linear tariff. So linear tariff means that the tariff or the total payment increases linearly. So that will be the case if the unit price P is constant. But if there is no such unit price, then the tariff or the total payment must be nonlinear. It can be nonlinear. Okay. So we consider the simplest form of second degree price discrimination, or the simplest form of a nonlinear pricing is called two-part tariff. Okay, it's called two-part tariff because it consists of two parts. So let's look at the equation. It looks like it looks actually very similar to what we just saw, but notice that there is no subscript I. Okay, so the total payment T is A plus P times Q. So you have seen many in other economics courses, in microeconomics courses, you have considered the situation where A equals to 0. So if A is 0, then tariff increases linearly from the origin. So that's called linear pricing, or sometimes we call it uniform pricing. But here it is slightly nonlinear because we have some positive A. So if there is positive A or fixed fee or the entry fee, then the average price is not constant. The average price changes. So if A is positive, then average price decreases. It's basically quantity discount or quality discount. Okay, so you have seen many quantity discounts, right? So if you buy more cans of Coke, then the price, the unit price or the average price is decreasing, right? So that you can pay a low average price if there is positive A. So that's basically quantity discount. So it's like, in basic microeconomics course, you have seen the total cost is decreasing if there is some fixed cost. So it's basically the same. Mathematically, it's the same. So if there is a fixed price, fixed term, fixed fee, A, then the average price is decreasing. Here, A, the fixed fee, affects whether to buy this good, but not how much to buy it. So how much to buy it is determined by the marginal price P. A only affects whether to participate in this transaction or not. Okay, so you have seen this kind of pricing mechanisms in many situations, like in theme park, in amusement park, you have to pay some entry fee, and then if you buy more, if you take a ride, then you pay more, right? Or there is some sort of exclusive supermarkets like Costco, or in the US, what is famous? Sam's Club. So in those supermarkets, there is some sort of membership fee. So that's fixed. So it doesn't depend on how much you buy it, how much you buy the goods in those supermarkets. But the member so you pay the membership fee A, it is fixed, and then you buy more than you pay the unit cost. Okay, unit price. So, or yeah, that's probably enough for our discussion. So this is the two-part tariff. It is used quite a lot in reality, and it is used a lot, I think, because it's easy to understand. Is the simplest form of a nonlinear pricing. Okay, so suppose that theta L is not very different from theta H, then it is more profitable to sell the product to both types of consumers. So if theta H is very large compared to theta L, then it may be optimal to ignore the low type consumer. So we want to focus on the situation where theta L is not very different from theta H. So both both types of consumers are solved in equilibrium. Okay. So that's one assumption that we want to make, and move on. So here is a graphical illustration of what I just said. So on the left hand side you see the situation where theta L and theta H are not very different. In this case, for given price which is below theta L, both consumers are solved. So both consumers make some positive amount of purchase in equilibrium. But if you see on the right, you see the situation where theta H and theta L are very different. In this situation, maybe the seller doesn't want to lower the price so that even the low type consumer make purchase that may not be profitable, because then the seller may have to lower the price too much. Okay, so in this situation, maybe the seller just wants to focus on the high type consumer. Okay, so but what I just said is that we want to focus on the left hand side situation. Okay, left case. So theta L and theta H are not very different. So assuming that both consumers are making purchases, the seller maximizes this profit function. So profit function can be written like this. From both types of consumer, the seller gets fixed fee A, so that is same for everybody. So fixed fee A is taken from both types of consumer, and there is P minus C. P minus C is the price cost margin. So you get this P minus C much margin from each unit of selling, and then you have the demand. So which is half times QL plus half times QH. So half of the consumers are low type and half of the consumers are high type. So you add them and multiply half on both demand, or the quantity demanded. So in this profit function, you can see that the L type consumer buys as much as QL, and high type consumer, H type consumer buys as much as QH. And we have 4 constraints, right? So you maximize this profit function subject to 4 constraints. So what are these constraints? The first 2 says that A shouldn't be too large. Otherwise what? Otherwise, these consumers will not buy this good at all. So these are basically the first two conditions are basically the participation constraints, so or the IR constraints. So you can move A to the right hand side. Then what it means is S minus A must be greater than 0. So what is S minus A? S minus A is the net utility that this consumer enjoys by participating in this deal. So S minus A must be greater than or equal to 0. So in that case, the consumer will be better off by participating in this deal. So the first two conditions, first two constraints are the IR constraints. What about the next two? As you can guess, the next two constraints can be understood as IC constraints. So what are the first the last two constraints? The last two constraints are the demand functions basically. So QL equals to DL. DL is what? DL is here. Look at the equations at the bottom. So DL is theta L minus Q. So that's the demand function. So DL is theta L minus P. Theta L minus P, and DH is theta H minus P. So QL is theta L minus P, and QH is theta H minus P. So these are demand functions. And how did we get the demand functions? We maximize the utility of the consumers. Okay, so we get the demand function by maximizing the utility function. And if you recall this the basic principal agent model, we got the IC constraints by maximizing the worker's utility function. It shows the optimal response to the given price, to the pricing scheme, to the contract. Okay, so these demand functions can be understood as IC constraints because they mean basically the same thing. It just shows how these consumers or how the workers will respond to the given contract or given pricing scheme. Okay, so the first two conditions are IR constraints, and the second, the last two equations are the IC constraints. So because these IC constraints must be binding, they are just equality constraints. Then the question is, which of the IR constraints is binding? And the answer is the IR constraint for the low type consumer is binding. The reason is SL for any given price P, SL must be smaller than SH. You can see that clearly in this diagram. So the area of blue triangle must be smaller than the larger triangle, right? So the consumer for any given price, the consumer surplus of the low type consumer is smaller than the consumer surplus of the high type consumer. Okay, so what that means is SH is greater than SL, strictly greater than SL. So if the IR constraint for low type consumer is satisfied, then the IR constraint for the high type consumer is automatically satisfied, and it must hold as strict inequality. So we don't have to consider the second inequality. So we ignore the second inequality and we just focus on the first inequality. And that condition, the IR constraint for the low type consumer must be binding. So it is not enough to be satisfied as inequality. It must be satisfied as equality, right? Otherwise, you can increase the profit by increasing A slightly without violating the IR constraint. So the logic is, the argument is basically same as what we have seen before, right? The IR constraint, you remember how we proved that IR constraint must be binding. So in this case, IR constraint for low type consumer must be binding. Otherwise, you can increase profit by increasing A slightly without violating the IR constraint. So what that means is A must be same with SL. So now we have this problem. So we maximize the profit function by choosing A and P, right? So A is the fixed fee, P is the unit price, and we have three binding constraints. The first one is the participation constraint for the low type, and the last two equations are demand functions, or the IC constraints for the high type and low type consumers. So if you plug this SL and DL, DH into the profit function, then you basically have a function of P only, and we don't have any more constraints. So you maximize the you solve the unconstrained maximization problem by choosing the right P. Then you get this solution at the bottom. So TP stands for two-part tariff, right? So the unit price, optimal unit price of this problem is given by theta H minus theta L over 2 plus C. And ATP, TP stands for two-part tariff, right? So ATP is same with SL. SL of PTP, and it can be written like 3 theta L minus theta H minus 2C squared over 8. So as you can see, if theta L is not large enough, then this SL will be negative. Oh, sorry, SL cannot be negative, but 3 theta L minus theta H minus 2C will be negative. In that situation, it is better off by not buying. Consumer will be better off by not buying this good. Okay, so that's the two-part tariff. And now we move on to the next topic, which is the most interesting case. In this discussion, we want to characterize the optimal pricing scheme, or the optimal nonlinear pricing. So it's the second degree price discrimination, but we want to find the optimal one among all possible pricing schemes. Okay, so the two-part tariff is a example of a pricing scheme, example of a nonlinear pricing. But there are many other possible nonlinear pricing. So instead of in two-part tariff, there is fixed fee, and then there is constant unit price. But the unit price doesn't have to be constant. Maybe you can think of very fluctuating a total payment. You can think of all crazy type of pricing schemes, but what we want to do is we want to find the optimal pricing scheme among all possible ones, which is not an easy task. So if you think about this problem, the size of this problem is almost impossible to solve, but we can do that. Let me tell you how. So one way to do it, one way to find the optimal nonlinear pricing is this. We consider all possible pricing schemes, and we calculate the expected profits of all possible pricing schemes, and choose the pricing scheme which gives the highest profit. This is one way, but as you can see, it is impossible to do that, right? Because we cannot consider all possible pricing schemes. We cannot calculate all possible the expected profits of all possible pricing schemes. It is simply impossible because there are infinitely many pricing schemes. But then there is another way, which is to consider the following problem. The problem is this. We consider the the profit maximization problem of the seller, and the profit can be written like this. So from L-type consumer, the seller gets TL. So TL is the total payment that the L-type consumer pays for quality QL. So quality QL is given and the L-type consumer must pay TL. And same for H-type. So the H-type consumer pays as much as TH, and QL is the quality that the high-type consumer enjoys. And half of them are low-type consumer, half of them are high-type consumer. So the profit can be written like this: T half times TL minus C times QL. C times QL is the production cost to produce the low-type good, and half times TH minus C times QH. C times QH is the production cost to produce the high-type good. And we have some constraints. How many constraints do we have? We have more than 2, right? So we have 2, but as you can see, there are I and J, I and J are L or H. So there are actually 4 constraints. 2 IR constraints and 2 IC constraints. So the first type of constraint is IR constraint. So theta I times Vi of Qi minus Ti must be greater than 0. So let's go back to the definition of the utility function. So utility of type I consumer can be written like this: theta I times V minus T. So this is the utility of type I consumer. So theta times V minus T is the utility. It must be greater than or equal to 0. Otherwise, the consumer will not participate in this deal, in this transaction. So this is the IR constraint, or the participation constraint. The next type of the constraint is IC constraint. It basically says that if you are I-type consumer, then you are better off by choosing I-type good than choosing J-type good, right? So that's the second type of constraint. So I claim that considering this problem is enough to find the optimal, the best nonlinear pricing. And why is that? There is such thing called revelation principle. Is the fundamental principle that is used in contract theory or mechanism design. According to this, in order to find the optimal mechanism, it is enough to consider direct mechanisms. What is direct mechanism? Direct mechanism is a mechanism in which the participants report their type directly, and the allocation is made according to the report. Okay, so this is called the revelation principle. The idea is very simple. It sounds abstract, so you may feel uncomfortable in this statement, but it's actually quite intuitive and it's quite simple. What that means is, if an allocation is implemented by some mechanism, and it can be implemented by a direct mechanism as well, because in any mechanism, each type of participants will do something, and you just allocate that to anyone who claim that I'm whatever that type is. Okay, so let's say in some situation, in some mechanism, in some pricing scheme, you are type 1. Okay, type 1 consumers are consuming as much as 10, whatever it is. Okay, then in direct mechanism, you claim that you are type 1 consumer, then you will consume as much as 10. Okay, in that way, any allocation can be implemented by direct mechanism. Right, it's quite intuitive actually. So if you if you want to know more about this direct revelation principle and direct mechanisms, then you can take the mechanism design course, or you can just Google it, revelation principle, then you'll have tons of information. And moreover, we can say that IC constraint and the IR constraints must be they must hold. They are necessary conditions. Okay, and I'll claim that the IR constraints and IC constraints and the IR constraints must hold, and you cannot increase the profit by adding more constraints, right? So the unconstrained optimum is better than constrained optimum. That's just simple math, right? That's we discussed at the very beginning of this semester. In math review, I prove that the unconstrained optimum must be better than constrained optimum. What that means is you can increase the profit by adding more constraints. So if there are some necessary conditions, then you just make the assumptions. You just consider them, and then you maximize profit, and you cannot increase profit by adding more constraints to them. Okay. So that's why considering this problem is enough. This is the problem where in which we just consider just the necessary, the minimal constraints. The minimal constraints are the IC constraints and the IR constraints. These are necessary conditions. So that we must consider this, but we don't want to add any more constraints. That's how we maximize the profit. That's how we find the optimal nonlinear pricing. Okay. So let me articulate why the IR constraint must hold. Sorry, IC constraint must hold first. IC constraint must hold because of this. Suppose buyer I chooses buy as much as QI star, then it means that buying QI star is better than any other options. So in other words, QI star and T star of QI star is maximizing the utility of type I buyer. Okay, so and what that means is this if QI star and TI star is given for type I buyer, then this must satisfy the IC constraint, right? Whatever the optimal pricing is, given the optimal pricing, the buyer buys as much as QI star. That means the buyer is better off by choosing this option than choosing any other option. What that means is this QI star must satisfy the IC constraint. Okay, and then next, the IR constraint. The IR constraint must hold because IR constraint simply states that it requires that the participants cannot be exploited. The participants' utility cannot be lower than the reservation payoff or the non-participating utility. And the IR constraint is so flexible that not buying anything is allowed. Let's look at the IR constraint. So look at the first constraint, the inequality constraint, the first inequality constraint. So it says theta times v minus t must be greater than or equal to 0. So let's suppose qi is 0 and ti is 0. In that case, the left-hand side will be 0. So left-hand side is 0 and right-hand side is 0. So 0 is greater than or equal to 0. So it is satisfied. So not buying is allowed here. So the IR constraint is quite flexible, so it must hold. It just states that the participants cannot be exploited, cannot be worsened by participating in this deal. Okay. So I probably stop here, and next time I will pick up this and explain how we find the optimal second degree price discrimination exactly. Alright, that's it for today. Bye.